All right, yeah, welcome back. This is introduction to new course that we'll be starting uh, very soon. So just to give us a quick background of this particular course, uh, machine learning. So we want to look at machine learning in details, looking at different subject area using Python. And when it comes to issue of machine learning, Python uh, is the key, is the best. So we have other program languages that could be used also, but they cannot matching Python when it comes to machine learning. Why? Because of the libraries that it comes along with. So we're going to be looking at this course as we journey gradually in this series. Uh, Machine learning simply is a part of a larger domain, which is AI. It deals with algorithms that learn from given data and make predictions. So basically, what machine learning does is just to learn from features supplied, then make output or predictions. All right, so uh, we have what is called learning algorithms, which is means that the concept is that you has features or attributes, or we otherwise call them independent variables. Okay, and we pass them into the machine, or we call it a model, and that's after some form of several iterations, the model try to build the system and produce an output. This output is otherwise called class or label or target or output feature or attribute or dependent variable. So we have features, we have attributes, we have variables that are independent, that are supplied to the machine or to the model, and a result is acquired, so which we call output. So this is algorithm. The concept is actually to adjust, to learn the model parameters, which is better through a number of iterations to maximize or minimize likelihood or error function on the output y. So this is the concept of machine learning. So we have some key concepts more. We have algorithm, which just explained the concept just now, which is this mathematical procedure used to find the patterns from the features. Every feature has patterns. For example, images and the rest of them, there are patterns. That are patterns that what denote the features. We also model the output of an algorithm trained on data, which become the system, entire system now that they need to wait to be deployed. We have training, the process of teaching, or that was called learning the algorithm using historical data that has passed, so are brought into the system, to the current situation, and processed to predict future occurrences. We have what they call prediction, using the trained model to make forecasts on new data. So these are the basic concepts of machine learning. We have types of machine learning. We have supervised learning, which could be classification or regression. Example classification are fraud detection, image spam detection, diagnostics, image classification. We have regression, risk assessment, score prediction. We have unsupervised learning, which is sometimes called dimensional reduction. We have text mining, face recognition, big data visualization, and image recognition. We have clustering as well, either hierarchical or means they are fall under biological, city planning, target marketing, and so on. Also have reinforced learning, which have gaming, finance sector, manufacturing, inventory management, and robotic navigation. These are the just a snapshot of the types of machine learning we have. We have supervised. Under supervised, it means in definition that learning with labeled data. Okay, labeled data or labeled example. So the goal is to predict outcomes for new data. So the types can be classification, predicting categories such as spam, not spam, cat, not cat, dog, cat or dog, spam, not spam. So for example, like that. So we have a regression predicting continuous variable that looking at y against x or x's, causes, price, temperature, and so on. So when you look at the same image here, we have input raw data, which is labeled, either cat or dog. These are called label. You already have names labeled to them, assigned to them to the features. So we have either cat, we have either cow, elephant, or camel. These are labels, known labeled, known variables, known inputs. Then we have a supervisor. Okay, the supervisor means that supervises the learning process. Okay, so the training data and the desired output. So the model is being supervised. That's why they call supervised learning. Okay, supervised because data is now labeled. So we run the algorithm, it is processed in the model, and the output is gotten. So output can either be elephant or camel or cow. So when it finishes the processing, so this is called supervised learning. So a learning that has supervisor that is monitoring the process, okay, based on the data that is labeled, trying to assign them to different category that is being they fall into. Okay, each of them must fall into a particular category. So, but it takes supervisor to do the separation. Okay, so we have also supervised learning. This one finding patterns in data without labels. This one non-labeled. You can see that input raw data here are not labeled. No elephant, no cow, whatever that is given. It is called unsupervised learning. No supervisor. That was the no supervisor. Nobody is monitoring the process of the labeled ones. And the example is called is clustering. That's a grouping similar customers together, for example, or association. People who buy X also buy Y. Or dimensional reduction. Dimensionality reduction means simplifying complex data. Okay, usually dimensional down to one dimensional and so on. So these are called unsupervised learning. So it has a unknown output, no training data set like formally like we do for supervised learning, where we have training data, we cut them to 2 X and Y and so on, 10%, 30%. I mean, we run this like that, but in this case, we only have interpretation, which means that the algorithm will process the data without knowing which nobody's supervising it. So the model will train the data internally, and they give us and try to separate them by itself without any supervisor, by itself to a required output. Sometimes there might be some mixture, which is somehow discrepancy in the system. But we will see more examples as we go when we are doing clustering, especially Erika clustering and the k-means. All right, so essentially, when it comes to issue of Python, I mean, machine learning, we understand that we have R programming, we have Python, we have Matlab, and many other powerful applications. But sincerely speaking, Python is the best. That is the truth. When it comes to maybe statistical analysis, where I choose R programming, because it has enough libraries to handle that. But when it comes to machine learning, Python is best because it has enough libraries. So everything is about libraries that comes along with them. So you don't need to arise from scratch or build from scratch. Just call them and use them. So Python already have inbuilt features and libraries for such. So to any level of deep learning you want to go into, so which R cannot handle without connecting to necessarily some Python API. So we have what they call essential Python libraries that you start with first before you go to other complex ones. The first one is called NumPy. This is fast mathematical operation on arrays of data. Okay, we have Pandas, which extract like data manipulation in Python. They give you a spreadsheet, rows and columns to manage data appropriately. We have a Matplotlib library, and also Seaborn, and this is creating charts and graphs. Right? We have a Scikit-learn. We have the most popular ML library, machine library, with over 100 algorithms. So these are just basic Python essential libraries. So we're going to see more of them later. So machine learning workflow is define the problems. First define the problem. What are we trying to predict here? What is the problem about? So that is the first thing we need to look at. What are we trying to predict? What is the problem on ground? Then prepare the data, clean and format data. Data must be clean and prepared properly, and choose algorithm. Start simple, then get complex gradually. Then train the model, fit the algorithm to train the model. The model will be trained, then evaluate performance. How well does it work on the data, or especially the test data? So make predictions, use the model on the new data. So this is how it works. So we see some pitfalls sometimes when we work with Python in machine learning. And one of them is called data leakage, which we need to avoid those pitfalls. So using future information to predict the past is dangerous. We use the past information to predict the future, the other way around. So overfitting model memorizes training data but fails on new data, which means that is bad data most times when we have overfitting. Overfitting can easily be caused mainly by when you have a lot of high training data. The training data is so high, but the testing data is so small or so low. So this is a model is too complex. If relative data is too complex, okay. So using feature or unseen data in training data most times this high accuracy and low testing accuracy. This high training accuracy and low testing accuracy is otherwise called the overfitting. And what we need to do most times is to do a proper data splitting, right? We do a proper data splitting and avoid target leakage. Most times we apply regularization, cross-validation, and add more data sometimes, or more features sometimes to balance the equation. We have also called underfitting as well. Model is too simple to capture patterns in the features. So there are patterns in the future that need to be captured by the help of the model. So if cannot be captured, it means the data is too simple, and model is too simple, or each result to poor prediction. In this case, now we have a very low training data at the same time, which also affects the testing data as well. So this is we need to add more features sometimes, and clean data, adding some missing values, and probably do some proper EDA, okay, exploratory data analysis to make sure that the data, we should not ignore data quality. Okay, garbage in, garbage out means that whatever you supply, that is what you get as a result. So if you have a bad data, you have a bad result automatically. So the data must be must pass through a proper EDA for you to have a good result. So we'll be looking also at the best practices by starting simple, with begin with basic algorithm before trying complex ones. Validate properly. Always test on unseen data. Understand your data. Explore before modeling. Most times we just put data inside. We don't do a proper exploration, and that is dangerous. So you affect the data a lot, or the result most times. And we need to do a proper feature engineering. Good features often matter more than fancy algorithms. Yes, and the algorithms sometimes does not really matter much. But when you have a good features, algorithm many algorithms can work for the future. Many algorithms can work for good features. Yes. Then you need to document everything. Keep track of what you try and fail, what you try and pass. So, and why. So it happened like that. Then so that you not repeat the same error again and again, so that you can move very fast. And we have some content to cover under this section. We have to look at introduction to machine learning, covering what machine learning is, types, which we are just talking about now. We look at the word examples later, and a view of the workflow. We also need to look at setting up the environment, installing Python using Anaconda or Miniconda, or introduction to Jupyter. We look at Jupyter environment, creating and running the notebook, installing necessary libraries like NumPy, Pandas, Matplotlib library, Scikit-learn, and Seaborn, and so on. We need to how we install them. Then we also look at Python essential for machine learning, the data types, functions. So we are not going to go into Python as a course in details, because it's a different course on its own. But we are going to look at essentials only for machine learning. What we need to learn, what we need to know as a machine learners in that category. So it won't be Python as a course, as a language, but as a machine learners, we need to learn some essentials from Python. So function loops and working with libraries, basic data wrangling and manipulations. So we're going to look at EDA as well, importing data from different environments and cleaning the data, handling missing values, duplicates, and so on. Then how to visualize our data using different kind of charts, histogram, box plot, scatter plot, heat map, and so on. Then how to look at the descriptive analysis and the statistics. So we also look at the introduction to Scikit-learn and the machine pipeline overview in Scikit-learn. We also look at the features and targets, which I have explained it theoretically. I want to look at them practically, how we handle them, how we split data at both training and testing split. Then we look at the in detail supervised learning, classification, particular, logistic, linear, logistic regression, KNN, decision tree, and we also look at neural network as well. In addition, this is just a simple example. Okay, we look at the metrics, how we manage, how they calculate the metrics, accuracy, confusion matrix, precision, recall, F1 score, what they mean, and how we calculate them. Then we look at the supervised learning more in regression, linear regression, polynomial regression, metrics such as MAE, MSE, RMSE, which come along with regression, R score. So we look at those ones as well. So because when you are dealing with machine learning, supervised learning, the result from we actualize from classification is not actually the same with we acquire for regression. People do not know this, so they just run it and they get whatever that attribute they get and they present the results, but they don't understand the difference between the two. So we are going to explain the difference between the two results and why it is like that. Then also supervised learning, you also look at the clustering, k-means, hierarchical clustering, dimensionality reduction, from looking at the piece analysis, and we first look at the model evaluation and improvement. How do we improve our model using cross-validation, parameter tuning with a grid search, and avoiding of grid search is not the only search we also have other ones. So we are going to we are going to do some comparison actually to see the best actually. So we also have avoiding what I explained as overfitting and underfitting. Okay, which I just briefly explained just now. We look at more real-world mini projects, choosing the data set, such as like Titanic, Iris, house price, and so on. I apply a full machine workflow on each of them and see how the difference between the two. We load the data and clean it. We perform EDA, we train the model and evaluate it. We improve the model and we present results. So we are going to go to advanced topics as well, introduction to deep learning using Keras and TensorFlow, and we're going to work more on time series data with deployment using the GUI such as a Streamlit or Flask. Then we have some bonus by adding some prepared notebook for each section, include quizzes, and for those of anybody interested, and use a Google Colabs if Anaconda is hard to install for some of us. So we're going to be seeing this as we journey in this series. So I want to thank you so much for listening. I will see us in the class as we journey. If you enjoy the class, you can just give us a thumb up, and if you want to share, you are free to do so. And we'll see when we start the class very soon. Thank you so much for listening. See you in the class.